Hello everyone. Today let's solve the problem number 698, partition of the K equal some subsets, right? So let's see what the question states here. We are given an integer array nums. See here, we are given an integer array nums, right? And an integer K as well. See, this is fine. We must check if we can partition the array into K non-empty subsets, right? So K non-empty subsets, right? So they've strictly mentioned K non-empty subsets, right? So we must check if we can partition the array into K non-empty subsets where each subset sum is equal, right? Where each subset sum is equal, right? So we have to go with the partition based on the array into K non-empty subsets where each subset sum is always equal, right? Is equal, right? So here, let me come with this one. Let's consider this example. See, they have clearly mentioned here 4, 3, 2, 3, 5, 2, 1 is the array, are the array elements. Basically, K we have been given 4, and output that we need to get here is true because it is possible to divide this one into the 4 subsets. See here, 4 subset means we have to display for this one based on the K we have to display the subsets, right? So 4 subsets we can display here. See, 5 we can consider this is it has to sum up to the 5. If we are considering only one word 5, then all the other this one subsets also has to sum up to the 5. That's what they have asked in the question as well. See, 1 comma 4, 1 plus 4 is 5, 2 comma 3, 2 plus 3 is 5, 2 comma 3 again with equal sums basically, right? So this will lead to 5 and 5 again, right? So we have see why we have considered 2 comma 3 twice here, because element 3 is present twice and element 2 is also present twice. We can't duplicate this one here within the answer, but if they have given 2 twice and 3 twice, then we can consider both this one twice, 2 comma 3 and 2 comma 3, right? So with equal sums. So here 4 subsets are 5, 1 comma 4, 2 comma 3, 2 times, right? So that will be every subset, this one sums up to the 5 itself, sums up to 5 itself, right? So let's go to the example 2. So nums we have been given 1 2 3 4, K we have 3 here, right? So the output that we need to get here false. So we have 1 2 3 4 here, right? So K we have been given 3 here, right? So now we this one, this is false basically, right? So this is false. It is not possible to divide this one into the 3 subsets of this one with equal sums basically, right? So this is fine. Now they have given us wonderful examples just for the sake of understanding. I hope the question part is completely clear along with the example part, right? Nothing but the input output part. Now let's do one thing. Let's quickly discuss the approach, right? Followed by the complexities, and then let's write the code. So first, let me consider first example, the same example here, so that it will be easier for us to understand the approach basically. So now, first thing I want to tell you here is we will be going with a backtrack approach, right? So we will be going with the backtracking or the recursive recursion, right? So backtrack is nothing but the recursion, right? So we will be going with a backtrack, right? So this is fine. First, we have to find the total sum of 20 here, right? So this one, you sum up this one, man. This you just sum up this one, right? When you sum up this one, what will get the answer? 4 plus 3 7, 9, 9 plus 3 12, 12 plus 5 17, 17 18 19 20. We have got 20 here, and K we have been given 4. First, what we are doing here, we are going with the total sum of all the elements, nothing but we got 20 here. Since and K we have been given 4, means we will go with 20 modulo 4 here, right? So this will be 0 quite obviously. 20 is divisible by 4, right? 4 into 5 is 20 basically. 4 5 are 20, right? Now 20 modulo 4 is 0, and each subset must sum to 5 basically, because 4 into 5 is 20, right? So 4 into 5 is 20, and we need to consider this 5 basically, right? So now each subset must sum to 5. So now what we will do, let's sort this one in the descending order. So this is the first step basically, right? So this is the first step. So next step, what we will do, let's sort this one in the descending order, the elements, right? So when we sort this one in the descending order, so we get here first 5 we have, 5 4 we have, this is also fine, 3 uh this one 3 twice we have, and 2 also twice we have, and finally 1 we have, 1 is present once in the array. So after sorting this element, this one in the descending order, we have in this format 5 4, 3 twice, 2 twice, and 1 once, right? So this is fine. Now let's move on with the second part. So this one, why we are sorting, this is just for the optimization purpose, man. This is just for the optimization purpose. Just remember this one. uh, let's go with the let's move on with the third step. Now let's start placing the numbers one by one into the k buckets, right? So let's start placing numbers one by one into k buckets. Each bucket should not exceed target sum 5. Again, each bucket should not exceed target sum 5, because here, as I have said in the first step, so we went with the total sum 20, and since 20 modulo 4 is 0, so each subset must sum to 5, because 4 into 5 is 20. So each sum each subset must sum to 5 basically, right? So now we are starting, now we have started placing the numbers one by one into the k buckets. Each bucket should not exceed target sum 5. We know this one. First we will put 5. So first element is 5, right? So we'll consider this one. So third step, first we will put 5 that forms one subset, right? So this is one subset. This is fine. The first element we have considered, this is one subset, right? So next we will go with this one 4, along with this one 4 plus 3. It is not, it will not happen. 4 plus 3 again, 4 plus 2 will not happen, because 4 plus 3 7, 4 plus 2 6, 4 plus 1 we will try. So where we'll be making use of the backtrack for this, so we will be going with the 4 plus 1, right? So 4 plus 1 will lead to this one, 5 basically. So we will consider 4 comma 1, right? So we will be considering 4 comma 1. So this is fine. You can just yeah, you can just go with a 4 comma 1 or 1 comma 4, it doesn't matter, right? So this is fine, 4 comma 1. And now next we will be going with a 3. So we are done with 5 and 4. Next we will be going with a 3. 3 plus 5 we cannot, this will be 8. 3 plus 4 will give us 7 basically, and 3 plus 2 will give us 5, right? So 3 plus 2 will give us 5, and 3 plus 1 will give us 4. So 3 plus 2 we can consider. So I'll just return here 3 comma 2, right? So this is one, or 2 comma 3 is also fine, but here 3 comma 2 we found first, so I'll just return 3 comma 2. So this one, duplicate, the same numbers will not be entertained here, right? So even if we get 2 comma 3 in different order, so it is not entertained, so we are not displaying that one, right? So it will be same. So basically we are not, they are not entertained, basically will not be displaying that. So this is fine. 5 4 comma 1 3 comma 2. And finally we have this one, we went with 5, we went with 4 and 1, right? So this is fine. And we went with 3 and 2, and again we have 3 and 2 that is left in the array. So we can consider this one and this one again, right? So we'll go with 3 comma 2, which will lead to the 5 again, right? So k we have 4, we have got 4, and we will stop further. We cannot consider as well, we cannot consider as well. And we have got the 4 subsets as well. K we have been mentioned 4 here, we have got the 4 subsets as well. Now these are the 4 subsets that we got. So this one we will return this one as answer, or in the result variable basically, right? So this one we will return in the answer. So sorry, we will not return this one, basically not the values. Basically we will be going with a boolean value. We have to return the boolean value accordingly with the question, right? So here in this case we have been given boolean value true, because we have got the 4 subsets, right? So we have got the 4 non-empty subsets, as k is 4 here, right? So the output that we got here is 5 4 1 3 comma 2 and 3 comma 2, which is equivalent to the output that they have mentioned in the question. This one here, if you cannot see this one, they have given the same thing, right? So this can be of any order, man. Don't get confused. They have given 5 1 comma 4 2 comma 3 and 2 comma 3. So this one 3 comma 2, this one it can be of any order. It can be 2 comma 3 or 3 comma 2, it doesn't matter again, right? So this one 4 comma 1 and 3 comma 2. So in this case we will be returning true, right? So the output that we got here is true, which is equivalent to the output that they have given for the question 1, or the example, sorry, example 1 within the question. So our approach works absolutely correct in this case, right? Simple steps, our approach works absolutely correct in this case. As we are done with the approach part, let's do one thing. Let's quickly discuss on the this one complexities part. Now we have the understanding of the approach, right? So let's quickly discuss the complexities part based on the approach that we discussed, right? So overall time complexity and the space complexity, we'll be going with time complexity and the space complexity. So overall time complexity would be big O of k to the power of n, right? So why it is k to the power of n here? Because we have to consider the worst case for the time complexity. It will be big of k to the power of n in the worst case, but it will be optimized with pruning, right? So practically it is for this one, practically for n less than or equal to 16, right? So overall time complexity would lead to big of k to the power of n. So what will be the space complexity here? Space complexity would lead to big O of k plus n. So overall space complexity would lead to big O of k plus n here. So this is fine. So why it is k plus n? Because we will be going with the k buckets as well as the recursion stack. Recursion stack would go up to recursion depth, or the recursion stack depth can go up to n, and we have k buckets accordingly with the question, right? So it is based on the k basically. Subsets here in this case we have to go with 4 subsets. Here we are going with the 3 subsets. It is not possible. Basically k we have been given 3. So k buckets, right? We have to consider k buckets, 0 of k plus n here in this case, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be k to the power of n and k plus n respectively, right? So as we are completely familiar with the approach and the complexities, let's do one thing. Let's quickly start writing the code, right? So now the first step here would be we have to go with the sum, right, initially. So for that I'll just consider the variable sum and let me initialize this one to 0. Also we have to go with the total sum of the array, first step, right? So let me go with the for loop here. This one will be int individual n of nums. So this one will be sum equals sum plus n. So this is total sum of the array, right? So let's go with the simple if condition. Means if it is not divisible, then equal partition is impossible. Then we have to return false, boolean value false in that case, right? So we went with 20 modulo 4. In that case 5, we got 5, right? So we considered basically the sum has to be 5 in that case. So if it is not at all divisible, if it is not divisible at all, then we have to return false, right? So because equal partitions are not possible in that case, so this one will be sum modulo k. If it is not equal to 0, then sorry, did I delete the parenthesis, or I have not given the parenthesis at all? So this is fine, man. If it is not equal to 0, then we have to return false in that case, right? So this is fine. Now let me do one thing. uh, So here, let's go with the target. Means each subset must have this particular sum. In the sense, I'll just go with the target. So this is equivalent to sum by k. So this is fine. Now let's go with the this one. We have to sort in the descending order, right? So let's sort just for the sake of optimization here. Means we are placing the bigger numbers first, right? So this one I'll just write arrays dot sort. This one will be nums. So this is fine. Next, if you remember, this was our second step. Next, what we need to do, I'll be making use of the nums, length of the nums everywhere. So I'll just initialize this one to the n basically. So this is fine. Let's do one thing, man. We have to go with a bigger number first, right? So we have to check whether bigger number is greater than target. If it is greater than target, then it is impossible, right? So in that case also we have to return false. So let me go with this condition as well. See here, nums of n minus 1, if it is greater than target, then we have to return false. So this is fine. Next, let's go with the k subsets. Nothing but each bucket stores current sum, right? So I'll just go with int here. This is fine. So this one will be buckets. So this one will be new int of k. This is fine. Let's do one thing. So we have to go with a backtrack. Means, yeah, we have to go with a backtracking in the sense we have to add and check with the each numbers, right? So we went with 5 initially, and then we went with 4 with 2, so it will not give 6, so it will not give 5. So then we went with 4 plus 1, then it gave 5, we considered that one. So we go on backtracking, right? So we have to go with the backtracking. For to perform the backtracking, I'll consider the this one, what do we call, another method. So this one, another helper method basically. So I'll just go with private boolean. So this one will be backtrack. Within the backtrack, I'll just consider two parameters here. This one will be nums. This one will be index as well. We need index as the parameter as well. So we need buckets as well. K buckets we need to consider, right? So this is fine. Also, we need target as well, right? So within this backtrack method, so let me go with the this one. What do we call index? First, if index is less than 0, then we have to return true because all the numbers are placed successfully already, right? So I'll just give here if index is less than 0, then we have to return true. Simple. Next step is let me pick the current number. We have to pick the current number. In this case, I'll just go with val equals nums of the particular index, right? Current number we have to pick. Simple. Next, let me go with the iteration part or the for loop. So this one will be int I equals 0, I less than buckets. So this one will be length of the bucket. So let me increment the I. So within the for loop, let's do one thing. Let's try putting in this bucket man. So in simple terms, I'll just go with if buckets of I, nothing but if the iterated value of the buckets plus value, if it is less than or equal to target, then so within the if condition, let me go with iterated value of the buckets equals buckets of I plus val. So this is fine. Now let me go with the simple if condition here. So let's go with a recursive backtracking here. Nothing but we have to go with the recursion, right? So now let's backtrack. I'll just go with backtrack. So what are the parameters that we need? So we need the numbers, quite obviously. Also index minus 1. This is fair. And also we need buckets k, and also we need the target. This is completely fair, right? So this is fine. Then we have to return true, and we have to return true, right? So here now we have to remove the number. In the case we need to backtrack, right? So we need to remove the number and backtrack. So for that, let me go with buckets of I equals bucket of I minus val. So this is fine. uh, we are left with the optimization part. Means we have to avoid the duplicate empty cases as we had discussed the same thing while during the approach, sorry. Yeah, so now let's write the same thing here. If buckets of I, if this is equal to 0, then let's break man. We have to break. So else we have to return false as well. You have to return false. This is nothing but the this is nothing but it is for the no valid placement, right? So this is fine. Else we are returning false. So we are done with the backtrack helper method. So let me copy this one and let me make use of this within the main function, right? Main method or main function, main method. This one can partition subsets method. So this one I'm speaking of, man. It's fine. Now we are left with only one step, nothing but return. So this one will be backtrack. What are the parameters that we need to pass here? Same thing, nums. Instead of index minus 1, we'll be going with the n minus 1 here. Again, we need buckets. Also, we need this one, target. This is fine. We are done with the coding part. So let me optimize this one and let me submit this one. Sorry, I should have run this one, man, before submitting. So I have directly hit the submit button. So this is fine, man. It works for all the test cases, right? So usually I do run first, then I hit the submit button. Now this is fair. This is fine. This works correctly for all the test cases, right? So we are done with the coding part, and the code, whatever we have written, works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach as well as the complexities. For now, this is it. Thanks for watching, guys.